morning, ma'am. This is Harini from 2nd BTech CSC B section in Srinivasa Ramanujan Institute of Technology. My roll number is 244G580507. Today my topic is multiplexers. Introduction to multiplexer. A multiplexer, often abbreviated as MUX, is a device that selects one of many input signals and forwards the selected lines into a single line. That means to given the input to a selected lines. It is essential in digital circuits where multiple data sources need to be managed. It is used to multiplexers to manage the data efficiently. Understanding multiplexers is crucial for designing efficient communication systems as data routing. Basic functionality. The primary function of a multiplexer is to channel multiple inputs into one output. That means we give multiple inputs at a time, but it gives only one output for us. It uses control signals to determine which input line to send the output. This functionality is foundational in reducing the number of data lines required in a system. Types of multiplexers. There are several types of multiplexers including 2:1, 4:1 and 8:1. Each type differs in the number of inputs it can handle, reflecting its complexity and applications. That means 2:1 multiplexer, we can use 2 inputs and 1 output and 1 selected line only. In 4:1 multiplexer, 4 inputs and 1 output and 2 selected lines only. 8:1 multiplexers means 8 inputs and 1 output and 4 selected lines only. Higher order multiplexers can manage more inputs, making them suitable for more complex system. Working principle of a multiplexer. A multiplexer operates using binary control signals to selected inputs. That means we give only 1 and 0. That means the binary numbers are 0s and 1s. For example, a 2:1 multiplexer requires one control bit to choose bit. For example, a 2:1 multiplexer requires one control bit to choose between two inputs. That means 2:1 multiplexer, we can give 2 inputs and it only takes one selected lines. The selected input is then transmitted to the output while the other input is ignored. We can send one selected line to that input in multiplexer. It only transmitted that data only. Remaining data is ignored. Truth table representation of the multiplexer. 2:1 multiplexer. The truth table is a useful tool for representing the behavior of a multiplexer. It shows how the output responds to different combinations of input and control signals. It responds the different input signals like 2:1 input signals, 4:1 and 8:1. For instance, a 2:1 multiplexer has a truth table that outlines the output based on one control signal. Applications of multiplexer. Multiplexers are widely used in communication systems to manage data transmission. That means we can use in large scalar database management systems. They play a significant role in applications like data routing, signal processing and switching. That means it uses in mobile companies and large mobile data routing places. In Microsoft's microprocessors, multiplexers are crucial for selecting data paths and controlling operations. And these multiplexers are also used in mobile signals. That like advantages of using multiplexers. Multiplexers help in reducing the number of data lines required for communication. Multiplexers we can use multiplexers in large communication. They does not require number of data lines. They reduces the data lines. They enhance the efficiency of data handling in complex electronic circuits. By consolidating multiple signals into one, they simplify design and reducing costs. Disadvantages of multiplexers. One limitation of multiplexers is the potential for increased complexity in control signal management. If not designed properly, they can introduce delays in signal transmission. Sometimes the data signals are erased or some not transferred. Additional multiplexers can be less efficient in systems requiring high speed data transfer. Multiplexer design. Designing a multiplexer involves determining the number of inputs and outputs needed. Logic gates such as AND, OR, and NOT are commonly used in building multiplexers. The design process also includes creating the truth table and ensuring signal integrity. Comparison with a demultiplexer. A demultiplexer performs the reverse function of a multiplexer, directing a single input to multiple output. In demultiplexer, we can pass a single input line and gives many output lines. While a multiplexer selects one of many inputs, a demultiplexer takes one input and sends it to one of many outputs based on control signals. Both devices are integral to digital circuit design and often work in tandem. Conclusion. Multiplexers are vital components in modern digital systems, providing efficient data management. Their applications span various fields including telecommunications, computing, and consumer electronics. Understanding multiplexers is essential for anyone involved in electronics and digital design. Thank you.